Okay, everyone. Hello. I hope everybody's doing well. Um, I'm going to share the screen to pull up what our schedule is for today. Oh, uh, I looked quickly at the interview threes. I went through everybody's interview three really quickly, and everybody's looking pretty good. You know, compared to the two other interviews, everybody's looking pretty good. So I haven't graded them, of course, yet, but they're looking good. Okay, so I'm going to share the screen. Okay, so today the goal is for us to do a little bit of review. Last week and the week before, people had some questions. Well, when did we do shear and bending? Yeah, last last weekend. It's weird with the echo, and I'm going to take it off. Is this okay if I don't use these things? You could still hear me?
Yeah, that's okay.
Okay. So last week was Thanksgiving. So 2 weeks ago, we did shear and bending moment diagrams. In the last couple of weeks, I've gotten some questions about shear and bending moment diagrams. So I thought I would do a short overview on them and answer any questions you have and just show you some summary. And then I prepared some shear and bending moment practice problems for you to work on. And I'm going to have us go into breakout rooms today and have you work through the problems, and the solutions are right here. And then you probably also noticed after Tuesday's class, I assigned our 27th homework, and it's our last homework. And it's a final exam review. Both this final exam review and the shear and bending moment practice problems are both multiple choice questions. So they're actually, and you know how multiple choice, you really want to, you know how much time you have on it, right? So if you know you have 60 minutes and you have 20 questions, you know you have 3 minutes per question. And some multiple choice questions are pretty short and might only take you 30 seconds. And then some multiple choice questions might take longer than 3 minutes. And it's kind of a balancing act. I don't know how much multiple choice you've done, but on the 2 licensing exams to become an engineer, and those of you who are interested in civil engineering, structural engineering, architectural engineering, you're definitely going to get licensed because you're designing items where a lot of people's lives are at stake, and it's a requirement eventually to become a licensed engineer. So you start working as a civil engineer out of school, not being licensed, but then eventually you get licensed. Those of you who are interested in majoring in other fields of engineering may or may not get licensed. However, there are 2 exams. Actually, I'm going to stop sharing for a minute so I could just see everybody. There are 2 exams to take to become a licensed engineer. The first exam you typically take in your senior year of college, and it includes all the courses you took your freshman, sophomore, and junior year. And those of you who took Engineering 5 have already heard this spiel. And then also I usually talk to the surveying class about it too, although some of you are in surveying right now without me. But the first exam is called the Fundamentals of Engineering exam. And it's a multiple choice exam. It's 8 hours long. And there are sections that you have to do, and then there are choices. So for instance, there will be questions on materials in there, circuits, programming, statics, dynamics, engineering economy, which is a junior level class. You'll see some physics questions, some math questions on there, some chemistry questions. So there'll be some questions that you have to answer in multiple choice. And then there'll be sections in the afternoon that you get to choose. Like if you are a mechanical engineer, you'll probably choose the mechanical engineering questions, which will include thermo, vibrations, fluids, etc. If you're a civil, you're going to take the civil questions, which will include surveying and thermo. You take thermo too, and fluids and structures. If you're an electrical, it'll be more circuit type classes. So the FE exam, the Fundamentals of Engineering exam, is an 8-hour exam, and it's all multiple choice. So even though as an engineering student, you've taken very little multiple choice, you've just taken it multiple choice probably in your GE classes, our engineering department designs our finals so they're multiple choice. So your statics final is multiple choice. Those of you who are in materials or took materials, materials final is multiple choice. Surveying final is multiple choice. I don't know quite what Carl does with the dynamics and strength of materials final, but I imagine that he probably does multiple choice too. So we're giving you exposure to what you would see in the FE exam. Now, all of you, regardless of what field of engineering you're in, you should pass, take that FE exam in your senior year of college, and regardless of whether you fail, you just keep taking it until you pass it. And it's offered every April and October. And the reason why is because 20, 30 years from now, when you decide you want to own your own company or you want to do a contract through the government and you have to be a licensed engineer, you would have to go back and take this FE exam. And like I said, the FE exam is based on all stuff that you've taken in courses, and you may have forgotten that in 20 years. In fact, in 10 years, you're going to forget a lot of stuff. So you definitely want to take the FE exam and pass it. And once you pass that exam, you're considered an engineering and training, an EIT, engineering and training. Then, once you graduate, you get your bachelor's degree in engineering, you work a couple of years in engineering, then you would wind up going back and taking the PE, the professional engineering exam. And that is specific to your major. So there's a ChemE, an industrial engineering, a mechanical engineering, a civil engineering. There's even a structural and a geotechnical engineering after the civil exam. So those exams are really specific to your discipline, and it does include things that you learned in school in your junior and senior year that were specific to your major, but it also, while you're working as an engineer, you're going to become more proficient on taking that exam. So those of you who are civil, structural, architectural engineering in your senior year, you're going to take the FE exam, and you're going to keep taking it until you pass it. Once you pass it, it's under your belt and you're done. The rest of you are going to do the same thing. You're going to take that FE exam in your senior year when it's the material's fresh in your mind, and you're going to pass it. And if you fail it, you're going to keep taking it until you pass it. So you're all going to have the FE exam under your belt. Then those of you who are civil, once you get your degree and you get your years of experience, if that's required, you're going to go and take that civil engineering PE exam. And there's 3 parts to it: a surveying part, a structural seismic part, and then the regular civil engineering exam. For you other engineers, you don't need to be licensed, and you don't have to take that licensing exam. You could wait until the future when you decide you want to be licensed. But civils, you're going to go right through it and get pass both tests. So coming back to what we're doing in statics, it's really important that you learn how to solve these problems efficiently, because when you're doing a multiple choice test, you want to be able to crank through the problems. So as you can imagine, there's no setup, there's no checking, there's as much as you want to do to solve the problem. And that's why we've approached solving the equilibrium diagrams by picking what is the most efficient equation to do first. And typically it's a sum of the moments about one point that has a lot of unknowns, so you could find another unknown. So in the last 2 weeks of school now, you're getting more exposure to solving statics problems using in a multiple choice fashion. So now I'm going to go back to the sharing the screen. Did I just share it? No, I don't think I did. I think I just pressed yes. Share screen here. Okay, you see the module, today's module. So I chose some shear and bending moment diagrams from past FE exams. And here are the problems, and then here are the solutions in here. I also selected final exam problems that cover everything, including components, finding moments, center of mass, centroids, trusses, frames, all things like that. So basically we have practice problems in shear and bending moment diagrams. There's about 6 or 7 problems here. And then homework 27 is a bunch of all statics multiple choice. So not only are you trying to figure out what the answer is, but try to figure it out in the most efficient way to save time. Okay, Your final exam, I believe, I'd have to look back and we're gonna tweak it, but usually it's about 20 questions and you have 3 hours. So what's that? 3 hours, that's 60 minutes times 3, that's 180 minutes. We have 20 questions. You basically have 9 minutes a question. So you might want to start timing yourself, but you want to get and to give yourself a cushion, say that you should get each one of these problems done in 8 minutes. So if you get it done in 2 minutes, you get a problem done in 2 minutes, you know you have an extra 6 minutes for another problem. Everybody getting that? So figure out about 8 minutes to solve each problem. So again, here are the practice problems for shear and bending moment. Here are the solutions, but these solutions are also these. I didn't pull out the shear and bending moment diagrams. So what I'd like us to do today then is let's do an overview in shear and bending moment diagrams. I'll answer any questions, and then I'm going to put you in breakout rooms and you're going to work through the shear and bending moment diagrams first to make sure you feel like you have a thumbs up on that. And then you're going to go through and do the rest of the problems. And since you just did the center of mass and centroid, you might want to, after you do the shear and bend moment practice problems, you might want to go to the last 2 problems in here are centroid and center of mass. So you might want to do those second and then do all the rest. But basically this class is set aside for you to work in groups to practice on these problems and help each other get through the problems in a quicker manner. You can share your suggestions. Okay, any questions yet on the final exam?
Can you remind us when the final time is? The final exam time?
Yeah, it's set up on the Friday. It's in the syllabus. Typically as instructors, we're allowed to pick the lecture or the lab time to have the final. And if we pick the lecture time, you would be having the final at 7 in the morning, which is crazy. So we picked the lab time. And on Friday, our lab time starts at 8. And our final on Friday is Friday, December 18th from 9 to 12. So if you actually look down here on our module for the final exam, it says Friday, December 18th from 9 to 12.
Got it. Thank you.
Make sure it's published. Yeah, it's published. Okay. So that's when our final is. We have no class the week of finals during our class time, of course, because you guys have other finals during that time. But if you want me to run a review session, I can. But let's decide that next week. So any other questions on the final?
Will we be
Normally I would have you do Scantrons, but I can't collect Scantrons. So I'll just have you do it on the test, I guess. I haven't, oh no, I'll do it as it online. It's gonna be online. I'm gonna design it so it's online. Like the online quizzes you've done. Okay.
So,
And actually I have a suggestion, because the online quizzes are a certain percentage of your grade, but I only gave 3 at the beginning. So I think what I'll do is your grade on your homework 27 and your grade on these practice problems, I'll put in there. So if you get full credit for homework 27 and full credit for the practice problems, maybe we should make that a, let me make that a homework. I have to change it somehow in the grading scheme, but let's make that a homework. And let's count it towards online quizzes. So that'll give you kind of a buffer on that grade. Okay, and I'll do the same for this. Do you understand what I'm doing? Because I only gave you a few online quizzes and I don't know how people did. Counts towards online quizzes. So this is kind of giving you extra credit in a way. Okay, so both homeworks 27 and 28 will count towards those online quizzes. Okay, questions? Okay, all right. So then I'm going to go now then to our summary. How are you guys all doing with shear and bending moment diagrams? I mean, I graded the quiz on it. Everybody seemed like they were doing pretty well. Do you need a little review or you want to jump to the questions? All right, I see only 5 people shaking their heads, so let me stop sharing for a minute. Do you want to you guys get your faces on the screen. Do you want to have a review on shear and bending moment diagrams, or you just want to go through to do the practice problems?
I think it's better to go through the practice problems.
Jump straight to practice problems.
Okay, so I'm only going to do one thing as a review, okay? I just want to remind you that there's this summary sheet, right? Everybody can see this? It looks like a little light to me. But the summary sheet is a great cheat sheet. If on the loading diagram, force goes up and down, the shear goes up and then down. Positive area. If it has a positive area with the horizontal here, then you have a positive slope on the moment diagram. Force down, up, negative area, negative slope. Distributed loads. Both of these are distributed loads, which would result in a negative slope. If it's a negative slope, positive area, the curve goes up. Negative slope, negative area, curve goes down. And then if you have a triangular distributed load, it brings you to this shape because it's going down, it's going down. Here it's concave up, concave down. All right, so this is a good cheat sheet to have.
What's the difference between 3 and 4?
3 and 4 are 5 and 6.
Numbers 3 and 4 on that list
Okay,
look the same to me.
They both have a distributed load going down. In the shear diagram, it ended up being, they are both a negative slope, but in the shear diagram, it turned out to have a positive area because we must have had a large load in the shear diagram going up already so that when you go down, you're getting a positive area. Here, you have a negative area. So if you have a positive area, the slope goes up. If you have a negative area, the slope goes down. And I had a discussion in one of my office hours with Dave and Miles, and they began talking a lot about integrals and derivatives and calculus and math. And, you know, that's not fresh in my mind, you know. I could certainly do all the integration for these problems, but you don't need to know it in this case. The important engineering part is what kind of shear is this beam being subjected to? What kind of moment is this beam being subjected to? And once you know the maximum shear and the maximum moment, then you could choose the member, the beam that will just withstand that load in the moment. So that's where my head goes in concentrating on the engineering part. But you guys, you can do all this stuff mathematically by doing integration. But you know, I'm not interested in seeing that. Okay, so that's the only overview I want to do then. So now what I'd like to do, any questions about that?
I mean, my only still hanging question is about the point moment. I don't know if you want to try to go over that or not.
Okay. So you guys, everybody, I want to hear everybody. Get your voices out there. Get off mute. Everyone get off mute. When the force goes up, what does the shear diagram do? Up or down? Force goes up?
Up.
Goes up.
Shear goes up. Force goes down, what happens? Shear goes down. So force goes up, shear goes?
Shear goes up.
Force goes down, shear goes?
Here goes down.
So when the force goes up, those are concentrated forces. If you have a concentrated moment that's going positive, what does it do in the moment diagram? Down. It's the opposite of what you think. Force goes up, shear goes up. It's the opposite for the moment. When there's a positive concentrated moment, the moment goes
Down.
louder.
Down.
If the moment is negative, if the concentrated moment on the beam is negative, the moment diagram goes
Goes up.
louder.
Goes up.
Up. Okay, so it's the opposite of what you think. That's
All right,
the
great.
most important thing to know. Force up, shear up. Moment positive, moment diagram down. Okay. All right, so let me set you guys up in breakout rooms. I guess, okay, how many rooms do we want? I think 3 people probably is good in each room, right? 1, 2, 3, 4. 4 times 5 is 20. Oh, 24. Let's have, do you guys want to be in groups of 3 or 4? It doesn't matter to me. Let's make it 4. The more, the merrier. So I'm creating 6 breakout rooms. Okay, you guys, so go in there and help each other. And remember, you got like 8 minutes to do each problem. Okay? All right, go, and I'll come in and out. Hello, this is Joanne. Hello? Oh.